Hey, what's up guys? My name is Cherno and welcome back to my C++ series. Today we're going to be talking all about copying and what a copy constructor is in C++. So copying refers to us copying data, copying memory, when we literally want to copy one object or primitive or just a piece of data from kind of one place into another so that we literally have two copies of it. A lot of the time we want to copy objects so that we can modify them in certain ways, but if we can avoid copying, if we can avoid unnecessary copying because we just want to read the value or we want to actually modify an existing object, we absolutely want to do that because copying takes time. So copying can be both a really useful thing that we actually need to make our program work the way that we want it to, but on the flip side, unnecessary copying is bad and we want to avoid that as much as possible because it wastes performance. So understanding how copying actually works in C++ and how to get it to work and also how to avoid getting it to work or avoid copying when you don't want to copy is very important to understanding the language and being able to write C++ code efficiently and correctly. So to demonstrate this in an effective way, I'm actually going to write a full-on example. We're going to write a class, it's going to be a string class, and we're going to talk about how copying affects that and what we can do to both remove copying when we don't want copying, but also even add copying so that we can copy correctly. So first of all, let's jump into the code and take a look at what copying looks like. So if I declare a variable, a primitive type like A, and then I declare another primitive type called B, and I assign it to A, then what I'm actually doing is I'm creating a copy of it. So A and B are two separate variables which have different memory addresses. Because of this, if I change B to 3, A will remain at 2. I literally have two different values in my memory. With classes, this works the same way. If I just have a struct maybe that's going to be a two-component vector, float x, y, whatever. If I have one vector here, which is set to 2 and 3, and I then create another vector called B and assign it to A, if I start modifying B and set the x to 5, then A.x is still actually going to remain at 2, because by doing something like this, I'm copying the value. I'm copying what A is into B. Just like with that integer example, they're going to be two separate variables which occupy two different memory addresses. Now, if you were to use the new keyword here and heap allocate this, so I'll do something like vector2A equals new vector2, we're actually going to need to either define a constructor or in this case, well, it'll be empty. If I then try and do something like assign B with A, this is going to be something completely different because the vector2 right now is a pointer, which means that by writing vector pointer B equals A, I'm still copying something, but I'm not copying the actual vector which contains the x and y variables. I'm actually copying the pointer. So now I have two pointers which essentially have the same value, of course, because they're copies, they point to different things. If I did something like B++ or whatever to modify the pointer, my A pointer would still be intact. But if I access the memory at that address and set it to something, in this case, it's kind of going to affect both A and B, because at the moment, A and B are both pointing to the same memory address. And what I'm doing here is I'm not affecting the pointer, I'm affecting the memory address. So that's just something important to note. When you actually do write an equals, when you use the assignment operator and you set a variable equal to another variable, you are always asterisk. You're always copying the value. The asterisk was there for references because with references, if you assign a reference to something else, you can't reassign references. When you copy, I guess, a reference or you assign one reference to another reference, you're actually changing the underlying thing that it's pointing to because references are just aliases. So kind of, with the exception of references, whenever you write code where one variable is assigned another variable, you are always copying it. It's just with the case of pointers, you're copying the pointer, that memory address, the numeric memory address, the number, rather than the actual memory at the pointer, if that makes sense. So with that in mind, let's write a string class and see about how we can make that copyable and what challenges we might face with that. So I'm going to write a class called string. Now I'm going to write this string class in a very kind of, I guess, old school primitive C++ way. I'm not going to be using like std vector or anything like that or smart pointers. I'm just going to write a base kind of string class implementation that is using just the raw metal kind of C++ features. And that's necessary because if I start using modern kind of C++ features to write this class, then it is actually going to automate a lot of this stuff for me. And in this case, it's not going to demonstrate my point about copying very well. So just keep that in mind. This isn't how I would necessarily write a string class nowadays, but it is a way to do it, and it's going to be a kind of nice bare metal way, and it's certainly not going to be slower. In fact, it'll probably be faster than if I was to use modern C++ features. So a string is made up of an array of characters. So the first thing that I'm going to do is place down an array of characters. I'm going to write a char pointer that's called mbuffer, and this was going to point to my buffer of chars. I'm also going to keep track of how big the string is by writing a variable called size here. Okay, that should be enough. So the constructor for string is going to take in a const char, which we'll call string, const char pointer called string. First thing we're going to do is calculate how long the string is so that we can copy the data from the string into our buffer. So I'm just going to use a C function called strlen or string length to actually get the size of this string. Now that I've got the size, I know how big I want my buffer. It's going to be the size of the string. So new char m size. Now we actually have to allow for the null termination character as well. So this should be +1, but I'm deliberately not going to write that so that you guys can see what happens. So the next step is going to be to copy the value from this pointer into our actual buffer so that our buffer is populated with all of our characters. I could write a for loop here just to keep it really simple. Something like this, really simple, to go through every character that we have in here and copies it one by one, like so. However, a much cleaner way to write this is just to use memcopy. So I'm going to type in memcopy. The parameters for this are the destination, that goes first, so don't screw that up. The destination, the source, and the size. So the destination is going to be mbuffer, the source is going to be string, and the size is in bytes. So how many bytes do we want to copy? M size, because at the moment, each character is 1 byte of memory. Now we are missing that null termination character, keep that in mind, but let's write something that can at least print our string and something that we'll be able to use to print our string. So I want to be able to use this with standard cout. So what I'm going to do is write an overload for that operator. So we'll write std output stream, operator shift left, std output stream, our string class. So this will be a const string reference string. This is going to return our stream, and before it does that, it's just going to shove string.getBuffer, which is a method I'm just about to write, into there. We could also make this operator a friend of this class, and then we'd be able to call mbuffer from this function because it would be a friend. In fact, I think I might do it that way. Instead of doing getBuffer, I might just copy this declaration, pop it in here, name it a friend, like so. And what that means is that I'll actually be able to write code such as this. So you can see I'm accessing a private member. If this code wasn't present here, that wouldn't be acceptable because mbuffer is a private member of the string class. But since we've declared this operator as a friend, we can now write code like this. Beautiful. So if I go back to main and I write my string variable here, I'll just set it equal to Cherno, and then I'll just pop it into cout. Like that. All right, looks pretty good. Hit F5, and there we have our Cherno string printing. You can see it's accompanied by a lot of other random characters because we don't have that null termination character. So let's go ahead and add that in. The way I'm going to do that is just when I allocate the buffer, I'm going to do msize +1. You could also use string copy, which we're not going to talk about for now, but I'm just going to allocate msize +1 to make room for that. We know that this string does have a null termination character, so to make this easy, I could write code like this, which kind of seems to copy over the length of this. If I hit F5, this will work, but this is working under the assumption that this string, that this char pointer is actually properly null terminated. If we can't guarantee that, just to be a bit safer, I'm just going to set mbuffer msize here equal to 0 like this, manually adding my own null termination character at the end of this, hit F5, and we should be good. And you can see that we are. We're finally writing some actual code in this series, really excited about that. Hope I'm not going too fast, I'm kind of trying to rush through this. This is mostly basic this is me kind of setting up the string class so that I can actually show you the copying, which is what this video is about. So if you have any questions about anything I wrote in this kind of segment or in other, I guess, maybe other sections of this video where I rush through things, the best place to ask these questions is to join my Discord server. There'll be a link in the description. If you just go to thecherno.com/discord, then you'll be able to join that server and you can talk to a lot of people about how all of this works. And I'll be there as well to explain this stuff to you if you don't get it. Okay, so we've got a basic setup here and everything looks pretty good. We've actually got a bit of a memory leak here that we should really fix, and that is when we allocate this new char array here, we never delete it. If we use a smart pointer or a vector, we wouldn't need to, but since we're using the new keyword and we're allocating a raw array, we have to actually delete it over here by calling delete buffer in the destructor. Okay, fantastic. So if we launch this code, we'll just verify that our program terminates successfully, and you can see it does. Now let's try to copy this string. So in this scenario, maybe I want to print out this string, and then later on, I want to make an adjustment to this string. I'll just call this second because it's our second string. Let's assign this to this string for now, and let's write some code that prints both of these. Okay, let's hit F5. You can see that we get Cherno printing twice, which is exactly what we expect. Everything seems to be working. Let's hit enter to proceed past this cin.get and terminate our application. Oh, look at that. It crashed. And if you look at the call stack, which I'm going to bring over here so that you can actually see it, it looks kind of cryptic, isn't it? It's inside ntdll, it's inside kernel 32.dll. We don't even know what's going on. It looks a bit weird. What on earth happened? So if I terminate my application, let's talk about this. what we did here is we copied the string. And when we copied the string, what C++ does for us automatically is it just takes whatever members there are here, which is basically what this class is made up. It's made up of a char pointer and an unsigned int, and it takes those values and it copies them into a new memory address, which contains this string, this second string of ours. Now here's the problem. What we have now in memory is 2 strings. And since it did a direct copy, something called a shallow copy, what it did is it copied this pointer. So we have 2 strings in memory, which of course have the exact same char pointer value. In other words, the memory address of this buffer is the same for both of these strings. And we get the crash because when we come over here to the end of this scope and both of these strings get destroyed, the destructor gets called, and we end up deleting this buffer twice. So we're trying to free the same block of memory twice. And that's why we get a crash, because the memory's already been freed. It's not ours. We can't free it again. So perhaps a better example to demonstrate how this really is the same, apart from just putting a breakpoint here, hitting F5, and then being able to mouse over both of these, you'll see that in this case, mbuffer has the memory address AE0440, and for second, we also have AE0440, so clearly the pointer is the same. Apart from doing that, let's say that we actually want to modify the second string. So I'll change the third character from E to A to get Cherno, which you guys love. We'll access the second index and assign it to A. Of course, in order to get this operator to work for the string class, we'll have to write it. So over here, I'm just going to write something that returns a char reference operator, index operator, unsigned int index. We're not going to do any kind of safety checks to make sure we're inside the bounds. We're just going to return mbuffer at index to keep it nice and simple. Okay, this works. Let's hit F5 and check this out. They're both Cherno. So why is that happening? And of course we also get the crash. So why is this happening? It looks like we've copied it, but we haven't. What we actually need to do is allocate a new char array to store the copied string, right? Because what we're doing now is we're copying the pointer, and what we have is 2 string objects pointing to the exact same buffer of memory, which means that when we either try and change one of them, it changes both of them because they're pointing to the same block of memory, or when we delete one of them, it's going to delete both of them because, well, they're pointing to the same block of memory. We want to actually copy that block of memory. We want the second string to have its own pointer, to have its own unique block of memory that it's pointing to, so that when we either modify or delete the second string, it doesn't touch the first string and vice versa. And the way that we can do that is by performing something called a deep copy, meaning we're actually copying the entire object, not just the kind of shallow features that we see on the very top, such as what actually makes up the object. Because if you look at the object in memory, it's a pointer and an int. That's all it is. But a shallow copy is not going to go to the contents of the pointer or where the pointer is pointing to and actually copy that as well. A deep copy is by definition going to copy the object in its entirety. So how do we make it perform a deep copy? Well, of course, we could write our own clone method or function or anything like that and have it just return a new string which contains, anyway, I don't even want to explain that because that's not the way you do it. The way that you do it is you write a copy constructor. And a copy constructor is a constructor that gets called for that second string when you actually copy it. So when you assign a string to an object that is also a string, when you try to create a new variable and you assign it with another variable which has the same type as the variable that you're actually creating, you're copying that variable, and thus you're calling something called the copy constructor. Let's write one of these. Now, C++ by default will actually provide you with a copy constructor. You can do several things with this copy constructor. The definition or the declaration for this copy constructor, the signature, is a constructor that takes in a reference, a const reference to the same class. So string, const, string reference, and then you can call it something like other because that's a sensible name. So as I said, C++ actually supplies you with one of these automatically. And what that does is literally a mem copy. It's just going to copy the memory of the other object, a shallow copy, into these members. So in other words, if we were to write one of these constructors ourselves, it would probably look something like this. mbuffer, other.mbuffer, and then msize, other.size. Okay, that is exactly what C++ kind of supplies us with. So that's not going to cut it here because we don't just want to copy the pointer, we want to copy the memory at the pointer. Now, if we decide that we don't want a copy constructor because we don't want to allow copying, we can just declare this copy constructor as equals delete. And you can see down over here, this code will not compile anymore. This is exactly what unique pointer does. If you look at my other video on smart pointers that I released like 2 days ago, link up there, you saw this in action when we talked about unique pointers. So that's how we kind of disable that. But what we want to do here is define our own copy constructor, which does that deep copy. So what I'll do over here is I'll copy size because, well, that is an integer. We can just shallow copy that. And then over here, what I'm going to do is just simply allocate a new buffer. We already know how big it needs to be. It needs to be m size, which we've already assigned up here, +1. We know that we're copying from another string object. So all we really need to do here is simply copy the other buffer, so other.mbuffer, into the buffer for this string class. And then we'll set this to be size +1. Over here, I can just write this because I know that the other string is already going to have that null termination character because it's a string and it has to. And that's it. That's all the code that I have to write to perform an actual deep copy in this case. So now if I scroll down here to my code and I hit F5 to run my code, the first thing you'll notice is that I actually have Cherno and Cherno written here. So the first string did not change. How awesome is that? When we change the second string, it didn't change our first string. That's pretty cool. And then when I hit enter, it doesn't crash. Our program terminates successfully. So as we discussed, if you write code like this, it will of course copy your string. If you decide to actually write a function here that prints our string, so I'll just write void print string, I'll pass in a string like this, and I'll just call stdcout string, and we end up using this function instead of these couts. I'll get rid of these couts, and I'll just call print string string and print string second. If I hit F5, everything appears to work, but what we're actually doing is we're actually needlessly copying this. If we come over here to the copy constructor and just write a quick message here that says copied string, it kind of looks like maybe we're doing one copy over here, but we're actually doing 2 more when we pass it into this function, and we can prove it by hitting F5. You can see that we get 3 string copyings happening. Ridiculous, because we don't want to be doing that. What's actually happening is every time we copy a string, we allocate memory on the heap, copy all that memory, and then at the end of it, we free it. That's completely unnecessary. What we actually want to do is just pass the existing string into this print string function, because we know that we're not going to need to copy it. We don't need another copy of it. We can just reference the existing one. And the way that we do that is by passing this by reference, which we can do by sticking a reference here. Now, this class will actually not be modifying the string. So what we should do really is mark it as a const reference. If we don't mark it as const, not only does that mean that we can actually edit this, so in other words, I can just write code like this. If it wasn't marked as const, maybe let's make this a character just so it's clearer, but you can see that if it's not const, I can actually edit the existing string, and if it's const, it can't. But it also means that we can't pass temporary R values into the actual function. We'll talk about L values and R values soon. I don't even want to get into them now because it's actually quite a complex topic, and this isn't meant to be about that, but eventually. All I'm saying here is that if we change this function signature to accept a const reference of a string rather than just a string, then if I hit F5, you can see we only have 1 copy, and that 1 copy happens over here when we assign a second with the value of string, because that actually needs to be a copy because we're trying to create 2 different strings. If we suddenly decide in the print string function, oh, actually I do want to copy, guess what? We can actually do that just by typing in code like this. So what I'm trying to tell you is, always pass your objects by const reference. Always. We'll talk about really kind of in-depth optimization about that in the future, because maybe in some situations it actually might be faster to copy, but for all intents and purposes, especially on a basic level, always pass your objects by const reference, because the function itself that you're writing, you can decide if you want to copy in that function, but there's no reason for you just to be throwing around copies all the time. That slows your program down. It's stupid. Whenever you pass a string, doesn't matter if it's your own string class or if it's just std string, always pass that by const reference. Sometime in the future, I'm going to make a quick video that actually talks about passing by const reference in a lot more detail and what advantages it gives us apart from reducing copies. But for now, just kind of keep that in mind. Anyway, I hope you guys enjoyed this video about copying. Hopefully you guys are experts now on how copying actually works in C++, when to use it, how to write a class that supports copying correctly. You need to specify that copy constructor. And hopefully you also know what copying does now and how preventing it or how mitigating it can kind of make your program run a lot faster because it's not just copying data and wasting CPU cycles doing that for absolutely no reason at all. If you guys like this series and you want to support it and you want to see more episodes, then you can do so by going to patreon.com/the Cherno. You'll be able to see episodes earlier. For example, I think this video is probably going to get out a day earlier for patrons than it is for anyone else. You'll also get access to a private Discord channel where we kind of talk about these episodes and what goes into them and plan them and all of that fun stuff. I think this was kind of the first video where we actually wrote quite a bit of code and got some stuff done. So I hope you enjoy videos like this, because now that we kind of know the basics of C++, apart from little tips and tricks, I guess, here and there, we're going to be actually writing code now. And especially when I start the new series that I'm going to. If you guys haven't seen the video I made on the weekend about the new series I'm starting, check that out for sure, link up there. But when we start those series, this is what they're going to be like. So if you're excited about that, hit the like button, support this series and everything I do on Patreon, because that's going to ensure that I can make more videos. And I will see you guys in the next episode. Goodbye.